Okay, just read up. Who don't have your topic 3 very sad one? Anyone don't have your topic 3 very sad one? If you have, right, tell me to self-mark, then just after that. Is there any question that you want me to go through? Is there any question that you want me to go through? You got a lot of water bottle here. Where are all this from? Sorry?
Question 2A.
2A. Oh, my question was where you all got where are you from?
Chemistry.
Chemistry. Wow. Okay. Question 14 is okay. 14 is not okay, right? Do you watch my video? You watch what? I never watch. Okay, you will watch. Okay, so maybe let me go through also. Okay, so question 14. Notice there are solutions here because our actually found. So for this, right? For what values of x is y increasing? Okay, so as the topic suggests, right, when we are talking about y increasing, it means that first of all, the first thought that comes to your mind is your dy dx should be more than 0. Okay, so this is the part where the word increasing will sound off to you, which is why, in case you do not know, you see the word increasing, you don't know what to do, simply differentiate. Once you differentiate, you get some marks. Okay, I'm going to skip through the differentiation. I assume that because that's just a lower order manipulation of short order. Okay, you will arrive at this part. This is your dy dx. Okay, this is your dy dx. And you want to find the x where dy dx is more than 0. Right? Because you are showing that it's increasing. Increasing tells you that the dy dx is more than 0. So if you want this to be more than 0, then what do you do? Well, very simply. Okay, this part is okay that I skip, right? Because it's just expansion and calculation, that's all. So I want to show that this is more than 0. I want to find the x values that allows this to be more than 0. Now if I look at my denominator, you can see that my denominator is a squared function. A squared function will always be non-negative. Agree? Right? A squared function will always be non-negative. Which is why if I'm solving this to be more than 0, I basically just need to check for my numerator to be more than 0. That's all. Because my denominator is guaranteed to be non-negative. Yeah, in fact, it will always be positive. X cannot be a, of course, because if x is a, then the denominator is undefined. If x is a, the denominator becomes 0. So let's focus on the numerator. Now, if I want the numerator to be positive, what does it mean? If I want the numerator, so you take a check here, my numerator, if I need my numerator to be positive, what does it mean? Okay, so you notice that all the coefficients are unknown. My function has to be always positive. My function has to be always positive. Just say it to yourself 5 times. What does it mean? Can I also say, I just repackage my question now, that being positive is saying that this y, if I treat this as my function, right, I want it to be above the x-axis. Can I say that? Can I say that? So what I want to sell you off is the new thing here, or the thing from the past, from JH3 is, when you say that it's always positive, it means that your graph is always above the x-axis. Now, that means we need the discriminant to be less than 0. Because above x-axis, no x-intercept, right? No real roots. The discriminant has to be less than 0. Say again. Say again. Why is it like this? Because, okay, if you consider this as a function, now I want this to be positive. I want this to be positive. Am I right to say, okay, if you consider x squared, am I right to say that I need this? Positive is the same as this. Now, if I treat this as a function, y equals to something, I sketch this graph. Now, I need this y equals, I need y to be positive. So, where will your y be positive? It's above the x-axis. Above the x-axis, that's all your y value will be positive. You all remember from JH3? Not taking photos, so I post. Okay, so you all remember this from JH3?
So 2a squared plus 2a
2a squared plus 2b squared. Right? 2a squared plus 2b squared.
So 2a squared is
2a squared. Yeah, 2a squared. Yeah, 2a squared plus 2. Right now. Is this part okay with you? No, okay? No, okay, ma? Okay, okay. I hope you're comfortable. Okay, so. So just this is the interpretation. Yeah, so if I need my numerator to be positive, that means the discriminant should be less than 0. The discriminant should be less than 0. Always positive is the graph of this function x squared minus 2x plus 2a squared plus 2 is always above the x-axis. It's always above the x-axis. My function is always positive. Means the y value is always positive. It's always above the x-axis. Only above the x-axis then it will be positive. Okay, ma? Okay, ma? Can I? First time, second time, it may not be the just video. So the discriminant is less than 0. Okay, so the discriminant less than 0. So therefore, if you calculate, you'll find that this is your discriminant, negative 4a squared plus 2. It's less than 0 for all a. Okay, so if you look at discriminant, the discriminant basically is just like a negative 4a squared minus 8. This is your discriminant. Irregardless of what a is, your discriminant is guaranteed to be less than 0. Okay, so here, let's follow the steps again. Let's follow the steps again. Okay, so we want to check my y is increasing. I want to find the x for which y is increasing. You check dy dx. You check dy dx to be more than 0. You found that your dy dx is some x squared minus 2ax plus 2a squared plus 2 over x minus a squared more than 0. Okay, now this with more than 0, it means that you need this. Just considering this portion, we need to check where is x squared minus 2ax plus 2a squared plus 2 more than 0. Okay, means that we need to check. We look at y equals x squared minus 2ax plus 2a squared plus 2 or more than 0. Y more than 0 gives us a graph. Want it to be positive. So find the discriminant is 4a squared minus 8, which is always less than 0. So what does it tell you is, irregardless what a is, the discriminant is negative. The discriminant is negative. This is always positive. Okay, ma? If this is negative, your function is always above the x-axis. Okay? Now, because it's always above the x-axis, your numerator is always positive. this one, therefore this is also always positive. So this part, the discriminant of the numerator is less than 0. Okay? Coefficient of x squared is also positive. This tells you that your numerator is always positive. Your denominator is also not negative. I can't use positive here because it's a A. So this positive, this is positive as long as x is not equal to A. This will always be true. That's why you see the answer is x more than A or x less than A. Anyone need me to say again? Need? No need. This one I got make video, so you can watch it as many times as you want. Plus after today it will be recorded a second time. Okay, now. Okay. Yeah, I will shall move on because I have all your question 1 is okay. Video is done also. Question 2. Question 2 is someone said it's not okay. Yeah. How to put the R formula? Okay. How do I get the pi over 3? How to get the okay, so this one, okay, the idea is this. I think in the biggest question I actually have is, on my mind, if I were a student doing this, is actually how do I know the R formula? How do I know the R formula? So A is okay, so I go to B. So I do B at time, again, I found that because the function is increasing, I need my dy dx to be more than 0. I need my dy dx to be more than 0. So that is the dy dx here. Okay, that's the dy dx here. Because I differentiated cosine to get negative sign. I differentiate square root 3 cosine. So from here, okay, I multiplied by negative 1 throughout. So you can see positive becomes negative. Minus becomes plus. Minus becomes plus. Because I ran positive, so I like everything to be positive. Yeah? So easy to work. Now if I ask you to solve this, right? You find that you can't really do. So there's some difficulty. Okay? So what might you do? What could you have done? One of the methods is by using R formula. Okay, one of the methods is by using R formula. Okay? So parallel context is if one day, right, or 3 months ago, when you are solving an equation like this, what would you have done? Right, so it's like you ask yourself, what would Beatrice do, or what would what would I do? What would you do? You do like something like that. Okay, it's possible that one, you could use R formula. So if you use R formula, right, you get this portion. One portion is one possibility. I will use R formula. So instead, I rearrange. This is 2 sine x plus pi over 3 equals to 0. Another possibility, I try to think of using tangent. Okay, I divide both sides. Then I use tangent x equals to negative square root 2. Make sense? This is one possibility. Okay, but why is it that so children, why is it that in this case I did not use this method? Why is this? Why is it that in this case, so you can see if I solve this equation, okay, so you consider a parallel cousin, instead of solving greater than 0, I solve equal to 0, right? So I can use R formula, that's I rearrange signs A, B, or I can put negative square root 3 cos x. Okay, sorry. Why is it that for this question, I cannot, try to force a tangent out? Anyone can tell me why would I not do this method for this one? Okay, so if you see I change some more than 0 equal, try doing this, I try doing this, right? So this one, then I try doing like that, more than, more than, more than. Instead of solving this, can I solve this instead? Is it possible that I do this instead? So help me predict this. Is this safe to go? Can I do this instead of using the R formula? This is the one I show you on YouTube, right? Why don't I use this one? I just do this one. So I shift sine x to square root 3 cos over, then I divide both sides by cosine, then I negative. Then I solve this instead. Yeah, also right? Okay, good. That's one reason. Because the reason is, how do you know if cosine x is positive or negative? Because if I divide both sides by a negative term, what happens to the inequality sign? It will stop. And if you look at this interval, your cosine can be negative, it can be positive, it can even be 0. So if I divide by 0 here, straight away I'm stuck. Okay, I pass away. So therefore, this method, it works for equation, but it doesn't work for inequality. So far, okay? So that's why I use the R formula. Okay, for the R formula part, okay, now you all need to show you how to represent AB, square root A square plus B square now. Yeah. Okay, okay, so I want. Are you all ready to go through practice set 2? Or not ready? Who's not ready yet? Who's not ready? Okay, then maybe I start Wednesday. Are you ready? Once you're ready, can you take out your topic form? I'll just give you about 1 minute in case you have not uploaded your topic 3 practice set 1. Can you do it now? Or you can upload a new one, those that you mark already. Okay? In the meantime, if you're done, you can talk to your friend a bit, right? Start. Endo means the key enters, exo means key exit. Okay, when there's an offender and the attacker, there's a defender. Right now, when there's a goalkeeper, there's a striker. Right? Where there is black, there is white. Where there is reduction, there's also oxidation. Right now. So same thing, after you do differentiation, then the next thing to ask yourself is can I reverse back? Can I reverse back? Can I reverse back to get a function? Right now. So this is why we are doing integration. So today I'm going to start on the numerator. So integration is seen as the reverse of differentiation. So listen, okay. So let's say if I talk about x squared, from here to here, usually some punctuation or symbolic notation. Okay, when we differentiate is 2x, right? Yeah, so when we differentiate, what do we do is the symbol that we use. We will use things like this. So we will use like, for example, differentiate with respect to x. That gives us the derivative, correct? So this is what we call the derivative. What else do we call this? We call this the dy dx. What else do we call this? Anyone? Y prime, y prime. What else can we call this? F prime x, F prime x. What else do we call this? Not G1. Not G. Gradient function. Or gradient function. Okay? Gradient function. Okay? Can So then from this, in case if you are not able to answer this, that means today you really never pay attention already. Okay, so first I want to answer is from here to here, If this is called differentiation, then what's the process called? Can I ask? Nominate someone. Sorry? Okay, Nathaniel, she can nominate you. What's the process from here to here? Integration. Alright, integration. Pure integration. Okay, so this process to here is integration. So from here to here, there's a punctuation. There's some. It's just that this here is integration symbol. You see something like what do you call it? Something like a triangle. Is it a triangle? Something like a triangle. Those music one. I don't know music Indian but you see a triangle? It's a triangle, right? It's not a triangle. I don't know what it's called. Curve. Then there's a delta x. Okay. So here, right, you find that if I integrate 2x, that just gives me x squared. So why is there a plus c? Why is there a plus c? We know this as a plus c, right? Okay. Okay, a few things. If I differentiate x squared, what do I get? Joshua, give me a name. Give me a name. Joshua. Okay, Joshua. 2x, okay. Joshua, give me a name. Sorry? Hello. Hello, if I differentiate x squared plus 10, 2x. Hello, give me a name. Vishal. If I differentiate x squared plus 1 million, 2x. So now notice, no matter what, okay, now I want to ask, all boys, I'm going to ask a girl. Howard, if I differentiate x squared plus pi is a constant, what does I get? Correct, I just get 2. So now notice that if I differentiate x squared, if there's a constant, right, whatever the constant is, it will be cubed off by differentiation. It will be cubed off by differentiation. So that's why you notice that when I go from 2x integration, let's say I'm integrating this to get this, right, there is a plus c. So what is this c? This c could be 0, but the c here is what we call an arbitrary constant. This is what we call an arbitrary constant. It's some constant that could have passed away during differentiation. We're just putting there a memorial here, okay, to remember the c. And this c is what we call an arbitrary constant. This c is what we call it. Because this c, it could have been thrown off during differentiation. We don't know what is it, but later on there will be ways to find. Okay? Okay, so just some notation. Usually, typically, how we write differentiation is we know that dx, right? This stands for differentiate with respect to. So in integration, how we so-called signify that we are going to integration, you'll see this curly sign here. Alright? Okay, so this is the integration symbol. Okay, integrate with respect to x. So if I write this, right, all you read off is integrate 2x with respect to x. Okay? Common mistake is people will write the front, they forget to write the dx. You don't believe, later you go and look at the classmate. I bet $5 still got people didn't forget one. Okay? A lot of people will forget the dx. Okay? And this, remember just now this is called the derivative, right? The derivative, right? So if I work backwards, what do I call this? If this is the derivative, this one is also what we call the. There's pro-Japanese, there's also those history students, there's pro-Japanese, then there is a. Okay, so derivative, then there's probiotics, there's also antibiotics. Okay, so there's derivative, that's what we call the antiderivative. Antiderivative means no. Okay, it goes backwards. So this is antiderivative. So x squared is what we call an antiderivative. You can also call it the integrand. You can also call it integrand. Yeah? You can also call it integrand. So a result or a product of integrand integration, we call that the integrand or anti-derivative. Yeah? Okay? Okay. So, you notice that the integration is slightly complicated because there are a lot of functions that you can differentiate to get 2x. So, what we do is, because we don't know what this constant is, we'll subsume it under an arbitrary constant which we call C. Okay, which we call C. Okay, so a lot of students may forget the plus C. I got this chalk in the office. So when I mark, last time when we mark on hard copy, I got the plus C chalk because I don't forget the C, so I printed on that plus chalk. Okay, so where C can be any constant. So this is what we call an indefinite integral. Indefinite because we don't really know what integral is because of the plus C. Alright, so there will be a difference between indefinite and definite. Definite means the limits are given. Indefinite means I do not know the actual value. I do not know the actual expression. There is a plus C, which I do not know what is it. So when there's a constant here that's arbitrary, my answer is actually indefinite. Okay? Indefinite because x squared plus c, this part is arbitrary. So in a way, very loosely put, it's like you are not very sure what's the answer because there's a plus c here. That's why my answer is not definite. It's not definite. Indefinite means that you are not sure of the answer. Okay? So with that, I will introduce to you the first power rule of integration. Very easy one, very easy one. Yeah, so if you know that when we differentiate x power n plus 1 by chain rule, what will this give us? Sorry, not chain rule, just power rule. What will this give us? Where did I stop? I will give you a name. Okay, so if I differentiate x to the power of n plus 1, what will I get? Wait, what's the? I thought you. No, that's not over already. Differentiate. This one you take so long. This one you take so long. Huh? X, sorry? N.
What?
Differentiate x to the power n plus 1, the front is n. Okay, don't worry. Tasha, don't worry. I'll come back to you. But before that, give me another name to help you. Tasha. Okay, Tasha. It's just a very simple question. Don't overthink. Don't panic. Stay calm. Very easy one. Okay. If it's too difficult, very simple. Okay, very simple. Differentiate x power 5. Huh? This one you don't know, I jumped down from here. First floor only. 5 power 4, very good. So with this in mind, if I differentiate x to the power of n plus 1, 5 is n plus 1. Now you treat the 5 as n plus 1. What should this be? Anyone can tell me? N plus 1. Very good. Okay, cannot. So can I also say this? If I differentiate this between this one I integrate also can. Right, so can I also say that if I integrate n plus 1 x to the power of n dx, that gives me x to the power of n plus 1. Is that okay? Can I'm just swapping right and left. Is that okay? Is that okay? So that Suppose I put a plus C, there's a C that could be there. Okay, they may have been two or few representation. Now, I mean definitely we don't always get something like this so nice, right? So maybe we'll get x power n. So n plus 1. Okay, try to listen, I don't know what I'm talking. Okay, divide by n plus 1 on both sides. And then c divide by n plus 1. Is that okay with you? I divide by n plus 1 comes over. So c over n plus 1. Because c is arbitrary. C divided by 7, you can still call it C. C divided by 10, I can still call it C. Because it's arbitrary. Okay, it's arbitrary. It can be anything. It can be anything. So I'm just going to call it, I'm still going to call it C. Because this is arbitrary. Right? You can substitute any unknown constant. Okay? With that, this is our formula here. Okay, we integrate x to the power of n. A is just a scalar. X to the power of n plus 1 over n plus 1. Okay, over n plus 1. Quite easy, right? Quite easy. Right? So far, okay? So far, okay? Can anyone need to repeat? So let me give you an example. Say, if I integrate x to the power of 7 dx, following this formula, I increase the power by 8 by 1, I divide by the new power. That's all. Okay? In differentiation, bring down the power go in front, power drop by 1, right? Right? So in integration, increase the power by 1, divide by the power. Divide by the power. So it's just like a reverse order of power. Today we are just learning this. Very easy one. You can master this, you are successful already. So remember in differentiation, first step, power goes in front. So called multiply the whole power. And power drops by 1. Minus 1. So in integration, we are just reversing back. This one comes, this is step 1, this is step 2. Power drops by 1, power increase by 1. Power goes in front, I multiply the whole power, so I divide by the new power. Okay, everything I say still don't make sense? Maybe you just remember this one. It's very easy. Very easy. Okay? Sasha, okay? Oh, okay. Okay, now I'm going to test you all. Okay. Integrate x power 5 dx. Okay, I'm going to ask you, you try to give me the answer within 5 seconds. Okay, integrate x power 5 dx. First I want to ask is Nicole. You want to tell me? X to the power of 6. Divide by 6. Okay, divide by 6. Okay. One more time, now without Wishong's help. Okay, okay. Okay, so Wishong cannot say anything, huh? Cannot say anything, okay. Integrate x to the power of 10 dx.
X to the power of 11 over 11.
Very good. Now give me another name.
R1.
I will ask you already.
Contact.
Something, okay. Integrate x to the power of 4. Correct. Give me another name. Plus c. Okay, Z. Integrate 3x power 10. Yeah. Okay, very good. So far okay, huh? So I think I asked around just a sample. So there is one disclaimer, however, is that your n cannot be -1. Okay, listen carefully, your n cannot be -1. So for example, if I want to integrate equate, say x to the power of -1. If I follow this formula, this will be x to the power of -1 plus 0 over -1 plus 1 plus c. -1 plus 1 becomes 0. Right, so it becomes undefined. Right, so it will not work. But so if n is -1, then what should be the answer? If I can't use this, right? If I can't use this when n is -1, then what should be the answer? What's the integral of 1 over x? What's the integral of 1 over x? To help you to answer this question, you all remember that, for example, the guy that is here, right? The guy that is here, somebody has differentiated to get 2x, right? So let me ask you, which function you differentiate will give you 1 over x? When you integrate, you will get back the answer. That function, if you differentiate, you get 1 over x. Integral of 1 over x will get back the answer. Correct. So actually it's just not. Okay, this is coming soon to theater part 4. So actually you are very fast. Okay, so just in case you want to know if n is -1, actually it's just not x. It's actually just not x plus c. Provided n must be positive. Just for your note, What happened? You're losing your head. So with that, let's try question 1.1.